let's see what comes here. We'll just print ARR once and see what has come of ARR here. So let's go to another one. Very, very similar question. There's another one here. Very similar questions, almost like that one. Given an array of n integers and the positive integer k, the task is to cyclically rotate the array clockwise by k. But you have to keep the first position of the array unaltered. So that's the only difference over here. Okay. So what is it saying? Cyclically rotate the array clockwise. Okay. Now, how would you clockwise rotate it? We'll look at it over here. It says move it 2 positions, right? So it means basically 20 and 30 have to move to the end and 40, 50 have to come to the start. So what happened here? First, 10 will remain at its own position. Okay. So I said 2 cyclical rotation means in the first rotation, 20 moved to the end. Okay, no, it's not like that actually. 50 moved here, 20 didn't move at the end, correct. 50 moved over here. Okay, got it. That's very important because the test case was not very self-explanatory. So we'll go here. So we are now on to the second question, sorry, the third question, which is basically called rotate array clockwise by k. So we are on this question, right? And the thing that's given to us here is this. Something like this. Okay. Now in the question, in the question, what it's saying is 10 you don't touch. 10 you don't touch. In the first one, let 10 be as is. In the first iteration, what you will do is you will move 50 over here. So you will move 50 and let the remaining be as it is. In the second iteration, what you're going to do is 10 will remain as it is. You're going to move 40 here, 50, 20 and 30. This is what happens. 2 here is not a position. 2 here is about moving it that many times. 2 here is about moving it that many times. Okay. How do we solve this question, everybody? Did you understand the question? We'll take another example just so that you're all clear. Okay. Let's try this on ourselves. Yeah, we'll take another example. Can you give me the output of this, the expected output of something like this? We have to move it only one time. We have to move it only one time. What would be the expected output over here? 10 is in its own position. When you move it once, what happens? 40. So you know what? 10 is in its own position. You forget about it. Just think of 20, 30 and 40. I'm saying do one rotation. What does one rotation look like? 40, 20 and 30. And 10 is there anyways. 10 is at the start anyways. Right? Okay. Very good. Yes. 10, 40, 20 and 30. If I look at it over here, that's the answer. 10, 40, 20 and 30. How do I solve this, everyone? How would I solve this? Give me your approach to this one. Try giving me your approach in this one. How would we solve this? Any thoughts, everybody? How do we solve this one? Okay. Take the array from k till the n, rotate in and add the kth element. Kth element or the first element? I think it should be the first element. Run the loop for given number of times. Take last element and insert it at ARR 1 position. Very nice. Very, very good. Basically, first of all, remove the first element. Right? So what we'll first do is we'll just end up removing the first element because that's unnecessarily, it's not going to help us with anything anyways, right? So I'll just say remove the first element. After I remove that, what am I going to do? Then I'm going to say rotate the array. And how does the rotate work? Rotate the array left by k times, right? Finally, print the first element along with remaining elements. Okay. What does this look like? Let's say, for example, if the example was given as something like this, let's say 7 are the elements and you're given something like, 1, 3, 8, 6, 7, 2, 5, something like this, right? And it says you have to rotate it 5 times. Rotate it 5 times. So you'll first remove 1, useless for us. We don't really need it. We'll add it at the end. We'll do one rotation. What does one rotation look like? Right? By the way, it's not rotate the array left because this 5 is coming. Rotate the array right is actually not a left, right. So I'll take 5 and put it over here. This is one rotation. I need one more rotation to put it over here. I need another rotation 7, put it over here. I need another rotation 6, put it over here. How many rotations done so far? 4 rotations, right? Then finally take 8 and put it over here. Okay, so it becomes 8, 6, 7, 2, 5, 3. Okay, and then I'll put 1 at the start. All right, does that make sense, everybody? Does this make sense? Somebody saying take an empty array, append starting element, and with for loop append last element and remove those elements in original array after existing element in original array, concatenate with new array. Yeah, that also works out. That's also a good point. You can also do it that way. Yeah, if you want to do it, you can do it that way also. So Anusha, that's a good one. You try it out. Okay. But others, you understood this one, what we did actually here? Okay. How do you rotate an array to the right? In Python, how do you rotate an array to the right? And even in Java, basically what do you need to do to rotate an array to the right? How do you rotate the array to the right? Let's say 1 is not there, right? You want to rotate an array to the right, this array. So this answer is, by the way, this. I'll just put that here. Answer is this. But let's say you have to rotate this array 1, 3, 1, 3, 8, 6, 7, 2, 5. If I want to rotate to the right, how does the rotate to the right work? If I want to rotate to the right, how does it work? Meaning, what's the algorithm, everybody? Just, it's a simple process, but how do I rotate it to the right? After removing the first element by subtracting the length of the remaining elements with k. Yes, you can also do that. That's also a very good option. So somebody's saying, I'll come to the, yeah, I'll come to other options as well. I'll come to them. Don't worry. Don't worry. I'll come to that one. Yeah. And then there are other cases also to be checked into that. So I'll come to that one. That's a very good example, right? So Siddharth, I'll tell you what the issue is with that, but that's a good one. But generally, everybody, can you tell me, if I just want to move this to the right, how do I move it to the right? I just want to move this by 1 to the right. That is, I want to take 5 and put it at the start. How do I do it? How does rotating work? Anybody? It's a simple process. How do you rotate this array to the right? Like, how does this rotating? We said we'll rotate by k times, but how can I rotate it even once? Anybody? I think it's a very simple process. We covered it 4 or 5 months back also. Any thoughts, everyone? Take the first element and add it at the end. No, but that's not how we're doing the rotation, right, my friend? Like, if you just look at it here, take the first element and add it at the end. Is that how we're doing it? No, right? How are we rotating to the right? Here also, what's the first rotation that we will do? This one. If I want to rotate to the right, how do I rotate it? Remember, it's a right shift, everybody. I'm just right shifting it. So I am not taking the first element and adding it at the end. What am I doing? Last element and put it at first. Absolutely correct. So what did I did? I took 5, put it at the start, and then 3, 8, 6, 7, 2. That's all. We always take the last element. How do we do this? Take last element and put at start. And this is how we're actually doing the shift. This is how we're actually doing the shift. Okay. I'll explain this with a better example. Let's say you have something like this. Okay. A, B, C, D, E, and F. Let's say I want to do a right shift, meaning what will I do? I will take F and put it at the start, right? So a right shift of this would look like F, A, B, C, D, E. Everybody understands this? Because I want to teach you one more concept after this. So do you all understand this part? This is just one shift. One shift. Okay. All right. But now somebody mentioned, sir, if you have 6 elements, like we have 6 elements here, right? If I want, let's say I say do 4 shifts. Okay. Let's say I'm saying do 4 shifts. What will happen in the 4 shifts? If I'm trying to say do 4 shifts, so A, B, C, D, E, F. In the first shift, F will be taken, put at the start. Next one E will be taken, next one D, and the next one C. So what someone said, if you are going to do 4 shifts, why don't you just take the last 4 elements, put it at the start, and then take the first 2 elements and put it at the end. Instead of doing 4 shifts, I will very clearly know if it's 4, just take the last 4 and put them at the start, instead of doing those many shifts every time. Is this also correct, everybody? To do a K shift, instead of doing the entire, like a for loop with K time shifting, I can just take the last K elements and put them at the start. And in the previous question, we saw how to do that. Take the last K elements and put them at the start. Will this work or not? Did you understand if this is working? So here I can just say, to shift it, I can just say shifted is equal to ARR. Take the last 4 elements we are saying, right? So take, let's say, n minus k, I would say n minus k onwards, right? 6 minus 4, 2 onwards, plus take up till kth, not kth element, take up till n minus k, right? This is what somebody suggested on the chat. My friend, this is what you had suggested, right? You're asking, why can't we just do this? Yeah. Okay. What are the problems with this one? What do you think will be a problem with this one? Can anybody think of that? What could be a possible problem with this? What could be a possible problem with this? There is one edge case here. Can anybody give me a very good? Here, what if k is greater than n? What if I said do 10 shifts? If I said do 10 shifts, then what should we do? Or let's say I said 11 shifts. Let's say 10 shifts only. 10 shifts, what should we do? So remember, everybody, that after how many shifts will this come back to the normal again, to the original? After how many shifts it will come back to the original? N, right? After n, it is going to come back to the original, right? So here, for example, if I do 6 shifts, I will get B, C, D, E, F. This is shift number 1, A, shift 1. Then I do C, D. No, again, I am also not doing the wrong way. It should be F, A, B, C, D, E. This is shift 1. Then E, F, A, B, C, D, shift 2. D, E, F, A, B, C, shift 3. C, D, E, F, A, B, shift 4. Just reduce the font a bit. Yeah. Then B, C, D, E, F, A, shift 5. And then A, B, C, D, E, F. So every 6 shifts, again, if I do another 6 at 12, at the 12th shift, it will again look the same. Right, everybody? So what can you tell? If I have to do k shifts and k is greater than n, should I do all those shifts or should I do lesser than those? How many should I do? Very nice, right? So what I'll end up doing is that if k is greater than n, let's say if k is greater than n, do k modulo n shifts, right? So in the case of 10, I will end up doing 10 modulo 6, which is equal to 4 shifts. I don't need to do, because of those 6 will just be getting to the usual part. Or for example, if I have to do 13 shifts, 6 plus 6, 12 will anyways get me the back to original. I just have to do 1 shift after that, right? Okay. So when I say rotate the array k times, I will just say rotate the array by k modulo n times. That will be better. If k is less than n, k modulo n will be k only. No issues there. If k is greater than n, it will greatly reduce the number of shifts we have to do. Okay. So now let's write down the code for it. First, I say n is equal to int input, the number of elements. Then ARR is equal to list map. Sorry, could not see. Yeah, correct. List map int input dot split. Right. and k is equal to int input. I take this. First things first is I do k is equal to k modulo n. No use of keeping that, right? Then what will I do? I'll say, first element, I need to take out the first element. I'll say ARR 0. Okay. And I'll say, you know what? Remove the first element, not really needed. Right? Just remove the first element. I don't really need that. Okay. Now rotate this array right. You have to rotate the array right by k times, and k we have already taken the modulo. So I'll say ARR is equal to, how would I rotate it right? By this way. Right? You can also run a for loop if you guys wish to, but when Python gives you this option, then why not? Right? So just use that. So I say ARR is equal to ARR n minus k onwards plus ARR up till n minus k. Okay. And then you say ARR dot ins. I think it's insert, or we can just do ARR is equal to first element plus ARR. So that way the first one gets prepended to ARR, and then I just have to print for num in ARR, print num and is equal to space. Okay. Let's see if this works out. Okay, it doesn't work out for us. What's the difference it's giving? It's giving 10, 50, 20, 30, 40. Whereas it should have been giving 10, 40, 50. Okay. So some mistake has come over here. Modulo plus 1, is it? No, it's not the modulo plus 1 issue. Let's see. Let's see if this n minus k. Okay. No, it's not that issue. Okay, we will very easily understand this. 0, 1, 2, 3, 4, 5. Right? This is the thing. When I say n minus k, means that I need to do, let's say, 4 shifts. So 6 minus 4 is 2. So I need to take these two onwards. Right? 2 onwards. I need to take that plus ARR n minus k. All right. Let's see what comes here. We'll just print ARR once and see what has come of ARR here. Yeah, this thing has not happened properly. Okay. What is the case? Why is it not happened properly? 2 modulo 5 is 5 only. So no issues there. In fact, okay. Let's print ARR here also to see has it. Yeah, we removed the first element, 20, 30, 40, and 50. And now, oh, okay. We made this mistake, everybody. And now I'll tell you the mistake we made. We took k is equal to k modulo n, but it's not k modulo n, everybody. Remember, we are not rotating the entire array. We are first removing the first element. We are first removing the first element and then we are rotating. So k is not k modulo n. K, in this case, I don't think it will make a difference, but I'm just telling you, k is equal to k modulo len of this, the new array. K is equal to k modulo that. It still won't make a difference, I think, but this is an important point. Okay, so we need to just be sure of this. And that's why, by the way, this is not n, right? So you understand the issue. Basically, the n has changed. Let it be n this here only. N is equal to len of ARR. That's the issue that we have. Because the n was the original array's input, right? We don't want that. We don't want the original array's length. We want the new array's length, that is without the first element. It all has to be around that. Right now, I think it's going to work out. Right? It works out now. And if I submit it, it'll work out. So very simple mistake we made. We took n. Yeah, it's a very simple mistake we made. We took n to be the size of the original array input. However, when we are trying to do the shifting, we are trying to do the modified array, the one without the first element. So that n should be length of the new array. Okay, that is after we've removed it. So it's not necessarily modulo plus 1. I mean, it's more about length minus 1. Does that make sense?
Does that make sense?
Is that clear, everyone? Is that clear for everyone? So why n minus k? Very good. Very, very good. Why did I take n minus k? All right. Very simple. Just look at it over here. What do I want to do? If I A, B, C, D, E, F. I have 6 elements, right? 6 elements. N is equal to 6. I say you have to do 4 shifts. These are the indexes. 4 shifts. 4 shift meaning what? First, F will go at the start. Right? F, A, B, C, D, E. Then E will go at the start. F, A, B, C, D. This is the first shift. This is the second shift. Then D, E, F, A, B, C. Third shift. And then C, D, E, F, A, B. Fourth shift. Okay. What actually happened? The last 4 elements come at the start. The last 4 elements. Did you understand this part? My friend who was asking n minus k. Did you understand? Last 4 elements came at the start. Okay. Meaning what? I need to get from index 2 onwards. I need to get the last 4 elements. Okay, hold on. That's the wrong slide. I went to the wrong slide. Anyway. So I need to go to the last 4 elements. I need to take the last 4 elements over here. Okay. How do I get the last 4 elements? I will start at n minus kth index. That's why I got n minus k, right? How do I know that? What is the last index? Last element is n minus 1. Second last index is n minus 2. Third last index is n minus 3. Kth last index will be n minus k. Did you understand now why we took n minus k? Clear? Super. Okay. Awesome. So that was this question.